This is Judah Phillips from Squark, and I'm here today to tell you about training data. Squark uses training and production data. These are the two files that you upload into Squark in a project when you create predictions. Since Squark is supervised machine learning, we learn from your training data, and we iterate a series of models to surface the best one for your data dynamically. And then we use that best model to apply to your production data. So a training data set is historic data. It's labeled data. It's the data from the past that we're going to learn from in Squark. It contains the known outcomes that you want to model and predict. In a training file, each row is a record, and each column is an attribute, or in machine learning lingo, it's called a feature. One column is going to be your label, or your dependent variable, also known as a target. Your other columns are going to be your independent variables, also known as predictors. So what you want to think about is, maybe what you recall from your business statistics class in college or in graduate school. But you're going to use your independent variables to predict your dependent variable. So your training data is going to have that information in it. So Squark's machine learning sees the data relationships in this training data and iterates a series of models using data science best practices from class balancing to feature engineering and selection to validation and cross-validation to early stopping and back propagation. We enable our system to see the relationships in your data. And then we apply what we've learned, that best model from your historic training data, to your production data. And we'll talk about production data and training data over the next few slides and give some examples. Here's an example of training data for binary classification. Notice that each row is a record. So row 2 is customer 7590. She's a female. Each column is an attribute, right? The features of the data. Not a senior citizen. She didn't get her telecom service at a partner. This is telecom data. She doesn't have dependents. She's been a customer for a month. That's the tenure column there. And you can see whether she has phone service, device protection, tech support, streaming TV. You can see that she has a certain type of contract, the way she pays, her billing, the monthly charges and her total lifetime charges. And then the most important, arguably, piece of training data is that labeled column. And that column in this case is the churn column. It contains a 0 or a 1. That's very binary. It could contain a yes or a no. It could contain green, blue, Squark, not Squark. It honestly doesn't matter what label you're using for your binary classification, as long as you have a label in your training data. So again, all you need to do binary classification is data in columns where each row is a record and one of those columns has a label that you want us to learn from. For multi-class classification, it's the same thing, except the target, the column you want to predict, has 3 or more classes. In this case, the contract column, it's the same data you saw before, has 3 classes. Month-to-month, 1 year, and 2 year contract. So this would create a multinomial or a multi-class classification that would predict the likelihood of new customers to use one of these contract types or be offered one of these contract types. Here's example training data for regression. This is the same data set. Notice how column T contains an integer or a real value. These are the total charges, lifetime value. Were you to select this column as your target or your dependent variable, Squark would perform regression.